Here is example 1 of 3 for calculating derivatives algebraically. We were before estimating slopes of lines on the graph and also using the calculator to draw them for us and have the calculator tell us the slopes. But now we're going to find them algebraically with our formula that we developed earlier, and that is the derivative is the limit of this difference quotient. Remember, I called it a difference quotient. It just refers to this fraction with all the f of x's and stuff. And we're going to do it with this formula here. Our f of x is going to be x squared plus 3. We want to find the slope or the derivative at the point x equals 1. So in the end, we're going to use this point x equals 1 and find out what is the slope of the line at that point. You could certainly also put this on your calculator and use the calculator to draw it. But we're going to talk about how we get this algebraically right now. So one thing you'll notice is we have to use this formula. The nice thing about these is that the formula is always going to be the formula you use. You never have to stray from it. So we've got to have f of x plus h minus f of x on the top. Now, we know what f of x is. That's right here. But if we're going to do this problem successfully, what I would, before you even plug it in, what I would try to do is f of x plus h. Now, this means taking wherever we had x and plugging in x plus h. So in this formula, x squared plus 3, I'm just going to replace x with x plus h, and so it looks like this. It's going to be x plus h squared plus 3. This represents the first part of this formula that we're going to plug in. So once I have that, now I'll plug all this in. Everything here is considered to be f prime of x, and so I'm just going to put that first because that means derivative. And now I'm going to plug everything in. So that is x plus h squared plus 3. I'm going to start with that on top. Minus f of x. Now I'm going to put that f of x in parentheses because I am subtracting it. We just need to be sure that we're, and then h is always going to go on the bottom. We just need to be sure that we're doing all the algebra correctly in these portions. Now, one thing that I did forget to put in here, and I'm going to just put it in now since I have enough room for it, is this limit as h approaches 0. So I'm going to put that limit in right here. That's an important piece of this because remember, if h is just 0 itself, then this thing's undefined. We want to see as this h gets really, really close to 0. So we're going to include this little thing as a stamp, basically. We could stamp this all the way through. It's going to be the exact same thing every step. But I have to have that in there until I actually plug 0 in for h. My next step, though, is just going to be foiling a lot of this out. Now, if I do x plus h squared, that's going to be x squared, plus 2xh when I'm foiling, plus h squared. Then I have the plus 3 sitting around out there. Then I distribute the negative into these parentheses, so negative x squared and then minus 3. All of this over h. Now, when I get to this point, one thing is I want to cancel out some stuff that I can cancel out. Notice that I've got positive 3, negative 3. I can get rid of those. I've also got x squared and negative x squared. I can get rid of those. So what that means is that I'm left with just a fraction of what I had before, 2xh plus h squared over h. And we don't want to forget about that limit. We have to keep carrying this through until we eventually substitute a 0 in for h. Now the other nice thing is that once I've gotten rid of some of those other things, I can now do algebra to get rid of the h. I can divide each of these pieces by h because they both have an h. So if I do that, I'm essentially canceling out this h and h in each one of those. So that is with those two, that's with those two. So now I have my new expression is going to be the limit as h approaches 0 of just, a much simpler thing now. It's just going to be 2x plus h. Now I don't have the divide by h going on here, and that's a good thing because At this point, all I need to do then is plug the 0 in for h. If I do that, if h is 0, then this whole thing is just equal to 2x. And so if I look back to the beginning, I had f prime of x equal to 2x. That's what I'm getting at here, is that I found my derivative to be 2x. So we're almost there, but we wanted to find the slope of the tangent line at this particular point. So once we have that point now, I can go to this formula and plug in my x value to find the slope. So I plug it in, f prime of 1 is going to be equal to 2 times 1, so that slope is equal to 2. Overall, after plugging my point in, that is my slope. And that's something that you could easily check on your calculator by graphing it and then having the calculator draw the tangent line for you.